Hi, this is question 9 of the Leaving Cert Ordinary Level, Paper 2 from 2021. As always, if you want a copy of these notes, then just email shanetroy@gmail.com. That email address should be in the description below. If you like these videos, just hit the subscribe button to get access to more playlists. Okay, so if we get stuck in. Now, the question 9 here has a lot of text, like all the longer questions have. This is the third question of section B. And it says the line segment SE. Okay, so I look down here at the diagram. There's a segment S as far as E. Okay, that's what's going on. Shown below represents an airport runway. Okay, it's not necessarily all that important, but it's good to have context. Try and imagine the scenario. The point S and the point E represent the start and end points of the runway, respectively. So that's your start, and that's your end. That's why it chose S and chose E, I guess. The diagram is drawn to a scale of 1 unit equals 250. So that's 250 meters. That's going to be 250, etc. Okay. Now, part A, part 1, which is a chunk of marks, 10 marks, says find the length of the runway and give your answer in kilometers. So we're told that each segment is 250 meters. So you could just write on it if you wanted, or just count them up. That's one way to do it. Okay. So I'm just going to do it just to make sure it's obvious what I'm doing. 250 to 500, 750, 1000, 1250, 1500, 1750, 2000, 250, 2500. So it's 2500 meters. Now I could have gotten that by multiplying 250 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10 units. And that just add on the zero is 2500 meters. Whichever way I get there, doesn't matter. I got there. Now to change from meters to kilometers, I divide by 1000. Okay. And if I do that, I end up at 2.5 kilometers. It's important to remember there is 1 kilometer is equal to 1000 meters. And that's it's I suppose assumed that you know that. And that's it. Now part A, part 2 says an aircraft starts at the point S and travels 1250 meters to a point L. Okay, so let's worry about there. So it travels 1250, so 250, 500, 750, 1000, 1250. So it travels as far as there, okay, and then it takes off, where it lifts off. From the point L, the aircraft makes an angle of 14 degrees with the ground. So if that's L, it's making an angle here. Now I've made an awful lot of mess in here on the diagram, but let's work with it. And I'm going to use a ruler and draw a line. It doesn't matter, I don't actually have to measure it. That's representing 14 degrees. Now, whenever I see something like this in degrees, I always go, is there a triangle being formed? But that's just me trying to problem solve. Plot and label the liftoff point L, so I've done that, and draw the aircraft's flight path for this part of its journey on the diagram above. So we've done that. Okay. So it might be just obvious there. I'll put in there C diagram. Now, part A, part 2 says find the total distance the aeroplane has traveled when it is directly above E. So you see there, okay, the plane's moving off. Here it's directly above E, so I can drop down a line. And I've basically made a right angle triangle. It's right angle there as an angle of 14. Now this base here is 250, 500, 750, 1000 is 1250. And I'm being asked to find the total distance the airplane has traveled. Now that's this distance here. Okay. Now, Pythagoras won't work here. It'll be always the first one I would try is Pythagoras' theorem. When I see a right angle triangle, Pythagoras can be used to find a side. I'm trying to find a side, but I need to know 2 of the 3 things in order for this to work. I only know 1 of the 3 things, so Pythagoras can't work. Then you're left with the sine, cos, and tan ratios. And I don't have time to go into them in detail, but simply put, these ratios are simply the measurement of all the different right angle triangles that exist. Okay, and they've written down for every angle, the relationship between the sides. Okay, so the sine of an angle, I should put that in there, is relating to the opposite sides of the hypotenuse. The cos, again, this cos, don't worry about sine, cos, tan, they're just words. They just come from Greek, whatever, is the adjacent over the hypotenuse, and tan relates the opposite of the adjacent. So all three sides are there. Now, we are looking here. This is the angle I have, 14. So this is my opposite. This is my hypotenuse because it's the side across the triangle. And this side I have is the adjacent. So I'm looking for the hypotenuse. I have the adjacent. So look, let's try it. Let's go through. I have an angle. Okay. Now I don't have the opposite and I don't have the hypotenuse. Sine can't work. Now I'll try tan even though it is cos. I have the angle. I don't have the opposite. Okay. And I have the adjacent. So tan would work. I know two of the three things, but I end up finding the opposite, which is not what I want. So cos is your best bet. I have the angle, I have the adjacent. What I'm missing is the hypotenuse, and that's what I'm trying to find. So cos of 14 is equal to the fraction 1250 over, I'm going to just call it h. Now at this stage, depending on how you want to solve this, okay, to get rid of the h there, I could multiply both sides by h, and I end up with h cos 14 is equal to h times 1250 divided by h. Now I did that in order to cancel the h's. That's what's going to happen next. They cancel and I'm left with this statement. H times cos 14 is equal to 1250. Now here, I want to get rid of the cos 14. I want h on its own. That's just what I'm trying to find. If I divide anything by itself, you can get rid of it. If I do it to one side, I must do it to both. Okay. Now, what the consequence of that is that cos 14 divided by cos 14, anything divided by itself cancels. You're left with h is equal to the number 1250 over cos 14. Now, that's maybe not as obviously a number as we might like, okay, but it is a number. And if I put it in there, apologies for the taskbar coming up. So the height is equal to the 1250. Let's type it in right. 1250. And the fraction on the bottom is cos 14. And just want to make sure that my angle is set to degrees. It is. Okay, press equal. And I got 1288.267. Okay, so that's 1288.267. I should check it again. Now it says give my answer to the nearest meter. Now these two numbers just don't matter. It's the 2 that matters. 2 is less than 4, so the number stays the same. It's 1288 meters. Job done. So the answer here on the next page hopefully makes sense of that. Okay, in a sense, it's a classic trigonometry question. It's not overly hard if you know your trigonometry. Okay, now I just realized from looking at the answer I messed up. I lost marks. It says find the total distance the airplane has traveled. Okay, I marked this and I should know. The airplane traveled that extra distance there. So the 1288 is what's from here up as far as here. Okay, but you did travel from here to here. It's not just when it was in the air. So I've represented that here in the answer. The 1288 plus the 1250 when it was on the ground adds to give the 2538. So look, I probably would have finished there if I hadn't copped with having the answer, which is a good time to point out that we should read the question carefully. Okay, and even reread it when you're finished to make sure you have answered it. It's a flaw of mine that I just kind of jump in and don't think. That's what I'm always trying to work on. Now the next one, part B, part 1. So look, this is trigonometry. I would be expecting sine rule and maybe cosine rule to come around at some stage, but we'll see what happens. This is worth it. You wouldn't know this during the exam, but it's a chunk of marks, 15 marks. So it says the aircraft flies from airport A to airport B and then on to airport C at the same altitude. The pilot records the flight summary on the given diagram. So it goes from A to B, then turns, goes to C. And it says find the distance from airport B to airport C and give your answer in kilometers. So basically, put a big question mark there. That's what I'm looking for. Eyes on the prize. Now, if you want to redraw the triangle, that's cool. Okay, maybe no harm. 47, 97, and 260. Now, don't worry about the labeling. So I'm looking, this is, I suppose, it's not right angled. So it's either sine rule or cosine rule. I've given a hint here. It's the sine rule, but we'll see if it works. I would always try problem solve the sine rule first. And for the sine rule to work, I need to know a side and its corresponding angle, and then another side and its corresponding angle. Now, if I know three of those four things, I can solve it. So let's see if I have, okay, I'm going to call that 47. I'm going to call that big A. Do I have the corresponding side? No, I don't. Okay. Now I just realized there is a problem here. I have the side 260, but I don't have the angle B. Now here's where you have to kind of make the leap. The angle B here, this angle I'm just putting the mark on, that's findable. Okay, if I get 180, take 97, take 47, I'm going to end up with that missing angle. Now I'm going to use my calculator so I don't mess this up. So it was 180, take 97, take 47. I have a bad habit of just doing it in my head and then I realize after I was wrong. So that is 36. So that angle there is 36, which was the angle B. So do I have an angle? Actually, let me take that 36 down here. It's confusing. Put it in there. Do I have an angle and its corresponding side? And can I relate that to another angle and its corresponding side? And I can. Okay. Now, once I can do that and can fill in my values, I'm going to leave it as A over sine 47 is equal to 260 over sine 36. Now, once I have that filled in, I've done pretty well. All I'm going to do now is manipulate this in order to find my unknown. I want everything else to move to the far side, so at the moment I can see the sine 47 is getting in the way. Now, one way to get rid of something is to multiply it by itself, because I'm creating the situation, something on top and bottom of a fraction which will cancel. If I do it to one side, I have to do it to both. Okay. Now, on the next line, what's the consequence of my action there? Well, they cancel. I'm left with A is equal to, now here's where you have to have a bit more knowledge, I suppose, in a sense, just to understand what I'm going to do. 260 times sine x is the same thing as 260 sine x. Oh no, x 47, sorry. Over sine 36. Now again, you could just program, let me just actually illustrate this. I'm going to program this even without me having gone that line there. So 260 over sine 36. Now, if I want to just go multiply by sine 47, okay, close brackets, I end up with what? 323.5. Okay, 323.5. Now it says to the nearest meter. Okay, make sure that was right. So if you're looking at the digit prior to the whole number, 5 or greater, the next number rounds up. So it's 324, and the units were no meters. No, kilometers. Sorry, my bad. Just read the question. Kilometers. A plane would go more than 324 meters if I was trying to use my common sense. Now, 9b part 2 says, actually, I might just put this up in the diagram here, that it is 324, okay, and that was 36. Now, even if I had no bugs notion what to do, and I put in the 36 there, I'd have got the attempt, okay, because it is a correct relevant step towards solving the answer. Now, when the plane was directly over Airport C, the pilot was instructed to circle until a runway was available. She therefore flew 10 kilometers away from C. Okay, so that's the airport. She went 10 kilometers. Now, this diagram's skewed. Okay, if you cop it, there's something special going on here. Okay, that's the radius. Now, let's read the question. She therefore flew 10 kilometers away from C before turning and flying along a circular arc of 70 degrees. So the plane turned and flew along this arc here. Okay. Then the path was, and then returning to the airport, this path was all flown at the same altitude. So again, there's no angles going on here in that sense. Okay. Just covering themselves. Find the total distance traveled. Okay. Give your answer in kilometers, correct to 2 decimal places. So it definitely traveled 10 kilometers and then 10 kilometers back. So I'll put that over here. So maybe distance is equal to 10 plus 10 plus, now what's the length of this arc? Now there's a hint there. The circumference of a circle is 2 pi r. Now that's a full circle. If I multiply that by the fraction of the circle, that it actually flew. It's 70 over 360, which is a fraction. Okay, it just looks weird. Now the r there, so if I keep going to, now pi is on the calculator, r is 10, if you cop that, times 70 over 360. Now that again is a calculator job, so let's clear it off. So 2, on this calculator, pi is on the second function, so shift, the pi button's down here, and then times the radius of 10 times the fraction of 70 over 360. And that looks like what I have on the page. Press equal. Now I got 35 over 9 times pi. Remember, pi is just a number, a little bit bigger than 3. So that is a number I can convert to a decimal, and it gives me the number 12.217. Okay, to 12.217. Now, if I wanted to, that's the distance the plane traveled on the arc, plus the 10 we start off with. So 12.217. That's 10, and 10 is 20, and 12 is 32. So the distance is 32.217. Now, the question says, give your answer in kilometers correct to 2 decimal places. I currently have 3. So the third decimal place is what matters. It means the number prior to it goes up by 1. So my answer is 32.22 kilometers. And apologies if that's gone kind of off the page there. I think that might be question 9 finished. Okay, that's the answer there in the notes. So again, if you want to copy the notes, just send me an email at shanetroy@gmail.com. And that is question 9. Okay, so thanks very much. And if you like these videos, just click to subscribe to get access to more playlists. Thanks.